If you've taken Java, taken C#, if you've taken another course, scripting, then you may have heard of the idea of a class. Well, before classes, there were structures. A structure is a series of variables that all have one name. Like you could have a patient structure, and then you have a first name for that patient, you have a last name for that patient, and you have the patient's birth date, right? And that kind of thing. And maybe you need another structure for vital signs. Every hour somebody comes and takes their vital signs, their current temperature, their blood pressure, stuff like that. So you would define a structure that has, all of the information about that patient, or all of the information that need to be incorporated into a vital signs. So we've been playing with that age and weight business a lot. The way you define, so we're going to define a structure that looks like that. But anyways, it's the struct keyword. And then you give it a name. And then inside the curly braces, you list the variables. And then if you want to, you could create a variable of that type right away. But you can also leave that off. So that's going to look something like this. I'll type it in a notepad, but there's absolutely nothing wrong with going ahead and firing up Visual Studio and getting your boilerplate in place. So, above my, my IO stream and stuff like that, or excuse me, below it, I want a structure. It's going to be called stats. Kind of a boring name, but okay. And then curly brace. And the person has a name. I better go and do a # include string. And what else do they have? They have a height in inches, which we're going to measure as a float. And then they have a weight in pounds. Good enough. Good enough. I'm going to go ahead and put a semicolon there, but I could go ahead and declare a variable of that type right then and there if I wanted to. Now inside main, I could create a person right there on the spot. Stats person1 equals, and then inside of my initializer list, I could give them a name, Betsy Ross. I could give her height, she's 60 inches tall, and I could give her weight, she's 150 pounds. And then another person, stats P2 is equal to Andre the Giant, who is 80 inches tall and weighs 400 pounds. Right? Just like that. Now if I want to print out somebody's name, cout p1.name. I really do need to put this in Visual Studio to prove that it works. And then cout p2.name, right? And if I wanted to calculate somebody's BMI, float BMI is equal to 703 times their height, weight. P1 weight divided by their height to the power of 2. P1 dot height times P1 dot height, right? Just like that. Then if we wanted to calculate the second person's BMI, we would just change those P1s to P2s. Now why is that a big deal? Because up to this point, we've only really been able to track one set of information at a time. One person's height and weight. And as we talk about arrays, we're going to learn how to keep track of multiple pieces of data at the same time. But this is collecting multiple pieces of data of different types about the same person. Like if you have a drawing program, you're going to draw circles on the screen. You're going to need an X and a Y position for that circle, right? But you're also going to need to know the width. You're going to need to know the line color, the fill color, how thick the line is, right? All that stuff would be useful for putting the circle on the screen. So you could define a circle class that had all of that information, an X position, a Y position, a radius, a fill color, a stroke width, all that kind of stuff. And really, it'd be a good idea to put our structure definition in a header file so that it could be shared between more than one CPP. So I made an empty project. I'm going to add a new item. I'm going to do the usual. Include IO stream, etc. Include string using namespace std. Int main. Inside main, I'm going to do a system pause. Okay, but above main, I want to declare that structure. So, struct stats. A person has a name, so string name. They have a height, and they have a weight. We could just put some comments. That's in inches, and that's in pounds. Now I'm going to make two people. Stats P1 is equal to, and I'm going to fill in that information. Their name, Joe, Bob. Their height, Joe is 6 feet tall, 72 inches. Joe weighs 200 pounds. And then somebody else. Stats person 2 is equal to Betsy Ross. She's 5 feet tall, so she's 60 inches, weighs 150 pounds. All right, in this business with the semicolon there, we haven't had to use semicolons in weird places like that, right? We hadn't needed to put them after our function declarations or our blocks of code. The reason why that's there is so that you could create some variables right on the fly. We could do like a P3 there. P3 means that, oh, by the way, as soon as you define that structure, I want you to create a variable for me as well. But notice that I'm not declaring the information inside of P3. But I could do so. P3 is dot name equal to Donald Trump. P3 dot height equal to 72 inches. I don't know how tall he is. P3 dot weight is equal to 220. Whatever. So you see what we did? We have a person whose information we have specified using this dot nomenclature, right? So you could write a function that took somebody's stats and calculated their BMI and printed it out. I think that would be worth doing. But first I want to make sure that this just works for y'all. Just get it to the point where it compiles, right? We don't even have any print statements, so it's not going to print anything. But I want it to compile and then just display, you know, press any key to continue, right? That's good enough. Is there an advantage to declaring it like this over like this? Well, personally, I'd rather do it like this. I'd rather declare my variables in the code rather than up here as a global variable. This created a global variable called P3. Global meaning that it would be accessible to all the functions in that CPP file. Okay, now I want to define a function that calculates and prints somebody's BMI. Or I guess it could just calculate it. It doesn't have to print it out. But let's go ahead and do something called display BMI. Doesn't even need to return anything. So I'm going to declare it as void. Void display underscore BMI. And what does it take? It takes a set of stats. Stats space st. So we need a variable that'll hold their BMI. Float BMI is equal to 703 times st dot weight divided by parentheses st dot height times st dot height. for POW ST height 2. I really like doing it. And then we can print it out. Cout st.name arrow space has a BMI of space end quote arrow BMI arrow ENDL. So that's my display BMI function. I'm going to go down here under the place where I declared those two people's stats, P1 and P2, and I'm going to call this function passing that stats block in as a parameter, as an argument. Display underscore BMI using P1. Display underscore BMI using P2. All right, Joe Bob has a BMI of 27. Betsy Ross has a BMI of 29. Oh, well and good. All righty. I hope that kind of makes sense. We're going to hit the idea again. What is a class? A class is a structure that also has functions attached to it. This display BMI could be part of the stats class. And so instead of being a function that was included in the main, it would be part of the stats class. And so you could just call S1 dot, or excuse me, P1 dot display BMI and P2 dot display BMI rather than calling a function and passing that in as an argument. Anybody got typos that they like? Nope, we're all good? Okay. Alrighty. Now structures and arrays go together just like peanut butter and jelly. Loops and arrays go together like peanut butter and jelly. So that's why I mentioned structures. This is actually chapter 11. So what I want you to remember, the definition for a structure. So a structure is a collection of variables with one name. The key word is struct. The syntax is struct, and then you give it a name, opening brace, close brace, and then a variable list. Type variable 1, right? Type variable 2, type variable 3, whatever, like that. And then a semicolon. Now when I said name, right, that's the name of the structure. Struct name, right, like that. And so if you were going to create one, then you would do struct name, you know, S1 equals, and then you'd fill in those variables, whatever the variables are supposed to be, 1, 2, and 3. Now that's not nearly as nicely laid out as my example up here, right, where I had something called stats and I filled them in like that. That's the generic version of it. Do you have to have any variables in it? No, but if you don't have any variables in it, why would you create a structure? It's like building a truck and then not hauling anything in it. All right, I want to go to the next chapter on arrays. And I noticed that our PowerPoint for chapter 11, and in fact everything past 7, I believe, aren't there. I could be wrong about that. So array is something that holds multiple values. If you've taken 1113, If you've taken a Python course, you call them lists. A list is a very similar concept. What is a list? A list is a structure that can hold multiple values, and you can append values to it, and you can delete values from it. An array is fixed in length. If you say I want an array and I want 10 ints in it, well, great, you got 10 ints. You want to tack on an 11th? Too bad, you got 10 ints. You want to delete one from the middle? Too bad. Now, when I say too bad, are you really stuck with it for 10 for the rest of your life? No. Your code could allocate a larger array and then copy all those values into it and then tack one on. That's kind of expensive in terms of processing. It'd be like every time you wanted to move somebody else into your apartment complex, you had to destroy the old one, create one that was larger, and then have all the people move into it. So arrays aren't the coolest thing in the block, in the world in terms of their ease of use in your code. But they're incredibly efficient. They're far more efficient than lists in terms of speed of processing. Why is that? Because they're guaranteed to be contiguous in memory. Contiguous meaning that they're all in a row with the bytes of the memory, which is great because chips have caches, which is really important for pulling information from a memory or from the disk, because it may take 10 times as long to pull data out of memory into the chip as it does to pull it from the cache into the chip. And it takes 100 times as long to pull it in from disk. So if you can read it all in one fell swoop into an array, and it's all in contiguous, then that's the fastest possible way of processing a list of data. But a lot of what we do is going to look a lot like what you did in Python. And that's good, right? It means you're already good to go. Now, unlike Python, you actually have to declare the type of the array, and you have to give it a length. If you don't give it a length, you better specify the length using your initializer list. You could get away with doing this, and this makes it look an awful lot like a Python list, right? Except you're defining it with curly braces. And that's completely moronic because this is supposed to be ints, right? So there you go. Something like that. Anyways, this symbol right here means this is an array. The variable that can hold multiple values of the same type. This is holding multiple strings, but it's got one name. The values are stored in adjacent memory locations. They have to be of the same type, unlike Python arrays. Python lists, where you could, have floats followed by ints, followed by strings, followed by turtles, followed by, anything like that. You can store all that in the same list. That's not true in Java or C++ or C#. If you create an array, they all have to be of the same type. I'm going to undo that because the next slide assumes that this is what we used. We want an array of ints. It's going to have room for 5 ints, and it's going to be called tests. Here we go. Int tests creates 5 spots. Each one of these spots has a memory address. I'm going to pretend entirely arbitrarily that our starting memory address is 1000. Byte number 1000. Now, in this language and in Java, an integer is 4 bytes wide. So this is going to be at memory address 1000. The next one is going to be at 1004. The next one is going to be at 1008, 1012, and 1016. So if we want element number... this isn't going to work. If we want element test subscript 3, index 3, here's how it calculates it. The size of an int is 4. It's going to start at 1000. So starting at 1000 plus 4 times the index value. 1000 plus 4 times 3. So there we go. That's our third element, number 3. Notice it says 4th element, but we've already talked about that. You're already used to the idea that in these programming languages, the first element is actually 0. The second element is index 1. The third one is index 2. So since we have 5 elements here, 0, 1, 2, 3, 4. So 0, 1, 2, 3. That's the third element, which we got to by doing that multiplication. 3 times the size of an int, which is 4, plus the starting memory address. Now, do you have to do it this way? No. Very rarely will you have to do it this way. But that's how the programming language, that's how the compiler figures out what element of the array you're accessing. So the length of the array is the size of an int times 5. And when I say length in this case, I guess I should call it the size. And this textbook does it in a slightly different way, and I'll find out again. The number of bytes that this occupies is 5 times the size of an int. And I've kept saying that the size of an int is 4. So this is 20 bytes long. And if we look, 1,000 all the way up to 10, 16, 17, 18, 19, that would be 20 bytes. So that's the data type. That's the name. This is the size declarator. And the size of an array is the number of elements times the bytes of each element. Now in this case, according to this text, we need to differentiate between the terms size and length. And if that was the case, I would much prefer to call this the length declarator, right? It's 5 long, and it has a size of 20. But they go ahead and say that that's the size declarator, and oh, by the way, the size of it is the number of elements times the number of bytes. Yeah, okay. Usually we care about the length of the array. This array has a length of 5. Why do you care about that? Because if you read past the length, you're reading into memory that is beyond the range. It's out of bounds. You sent your cow to go eat grass in somebody else's farm. You don't know whether they just sprayed poison on it or something like that. It's bad news. So the size of the array is the total number of bytes. The length of the array is how many elements it holds. This holds 5 elements, and it's 20 bytes long because each int takes up 4. If it's a long double, well, doubles occupy 8 bytes. And so 10 8-byte types would be a size of 80 bytes. Why do you need to know that size? Well, you may need to write out a file and write out that entire array in one fell swoop, and you would say, okay, write out these 80 bytes starting at this memory address. Usually, I mean, in the C++, the goal is to not have to be that primitive. Named constants are usually used as your size declarator. I want my array to be of size. Now see, here they're using the term size in, exact opposite definition of what they use here. Right? The length of my array. Like that. This eases program maintenance if the size of the array needs to be changed. Somebody tells you that no class will hold more than 30 students. So you hard code, the length of your array to 30, and then you find out that your school fired some teachers, and so, class sizes have been moved to 50 students. You go and modify your code to make that 50 rather than 30. Rather than have the number 30 hard coded all the way through your program in all your loops and everything else. Accessing array elements. If this is our array, that's array subscript 0, subscript 1, subscript 2, subscript 3, subscript 4. Let's play with some arrays. Let's go take our code here. Let's stick it at the very top underneath main. And I'm going to put a comment here. The rest of this shows structures. And then the top of it's going to say this shows arrays. Alrighty. How about some ints? We're going to make an array called nums, and it's going to be 5 long. Let's place some numbers in there. Nums subscript 0 is equal to, and let's just put in some of our favorite numbers, 100. Nums subscript 1 equal to 200. Nums subscript 2, that IntelliSense bothers me when I don't need it, but is equal to 300. Num subscript 4 equal to 400. And nums subscript 5, this is bad news, I've skipped one. Why did I say that was bad news? Because if your number of your index ever gets up to that size, it's a problem, right? Because we're doing 0-based counting rather than 1. So what went wrong is I forgot to do subscript 3. Num subscript 3 is equal to 350. Just going to kind of squeeze that in there. Now just for funsies, let's print out that array variable, nums ENDL. You could do that in Python and it would print out the list separated by commas. I don't think that C++ is going to be so nice. Yeah, it just prints out a memory address. That's the memory location in your computer. That's the byte number where your array starts. That's not terribly useful to us. Instead, you'd have to use a loop to print it out. Okay, now the textbook told us that we ought to declare constant with that 5 in it. So above int nums5, I'm going to do that. Const int nums underscore len equals 5. And then I'm going to change that 5 underneath to nums underscore len. Nums underscore len. So change that nums to just printing out nums 0. You know, the first element of the array is 100, so when it runs, I better see 100 pop out. And I do, it says 100. All right, 100. But do you want to print them all out like that? No, you really want a for loop to do it. You could use a while loop as well. So I'm going to comment that out because we're going to use a handy dandy for loop for it. For, and I love using I as my index variable. If I see I in my code, I know that I'm in it as an index variable. So for int I is equal to 0, I is less than, I'm not going to type 5 because that's a magic number. Instead, I'm going to do the constant. Nums underscore len, semicolon, I plus plus. Now do cout, arrow, nums, subscript I. Nums, subscript I. Arrow, followed by quote, space, quote. And then after we're done printing the loop, let's print a ENDL. So cout, ENDL. Why am I doing that? So that all the numbers will be on the same line. Right? Every other time we've printed stuff, we put every item on its own line. But this way the entire array is going to be all in one line, and it's going to be separated by spaces. Alrighty, and then it printed out our array, 100, 200, 300, 350, 400. We're going to wind up printing arrays over and over and over. What would be nice is if we defined this as a function that we could call. Let's write a function that'll print out an array. I'm going to go above main, probably below the struct, and write a function that will print an array. So above main, but below display BMI, below the struct. It doesn't have to return anything. So void print underscore array. What's the name of my array? Well, I don't know yet, but it's an array of ints. I'm just going to call it array. That's a pretty boring name. But I also need a size. Excuse me, length. It's just going to be our for loop again. For parentheses int I is equal to 0, I is less than length. I++, and then the same business inside the braces. Cout, arrow, arrow, array subscript I, arrow, arrow, space. And then after the for loop, let's print out an ENDL. So now that I have that, I better actually test it out. I'm going to come down here below my loop that printed out the array, and I'm just going to call print underscore array, and I'm going to pass in the name of my array, which is nums, and then the length of the array, 5. Nope, just kidding. I'm actually going to use my constant, nums underscore len. Now that should print out our array twice, right? And I could comment this one out if I didn't want to see it twice. There we go. It printed it out twice, 100, 200, 300, 350, 400. I don't like seeing it twice, so I'm going to comment out this first for loop. Do you feel like leaving it in there? That's cool by me. Now, why did I put it in a function like that? So that I could print out the array any old time. What if I wanted it to print out an array of strings? I could overload this function. Overloading is when you write a function that does something different based on the parameter types, and so it accepts different parameters. Good. Maybe we'll hold off on that. Are we all good, or anybody need some typing help? Oh, one thing to note. Python sure is nice, right? Because it'll tell you the length of the array if you want, right? All you have to do is this. Length of array, don't type this, x is equal to the length of the array. Great, now I know the length of the array. Or for I in range, length of the array. There's no such nicety in arrays for C++, because in this language, arrays are not classes. It's just an address in memory. So there's no way that they could have provided us with a function that keeps track of the size of it. Now you can do something that will tell you the size of the array, but it's not guaranteed to work inside of functions. But it will work in the same code that allocated the array. So here we have created an array. Let's just print out its size. Excuse me, its length. So int length is equal to, I'm just going to say int len, is equal to the size of the array, size of nums, end parentheses, divided by a size of an int. And then if I printed that out, it would tell me that the size of the length of the array is 5. Cout, arrow, arrow, length of array is space, end quote, arrow, arrow, at len, arrow, arrow, endl. That's how you have to calculate the size of an array. And like I said, it works in the same block of code where you declare the array. It doesn't work so good if that array is being bounced around into a function. That's why a lot of functions that you write in C++ will take a length. If you don't know the length, how do you know how high your index value can get? Now somehow, via a miracle, they have provided a for each syntax that does not require the length of it. We may as well use the for each syntax down here. for int v for value, colon nums, cout, arrow, arrow, v, arrow, arrow, endl. And then after that for statement, cout. Actually, I'm going to take out this endl, right, so that it'll print it all in one line. I'm going to change that to a space, just like on our other one. So cout, arrow, arrow, v, arrow, arrow, double quote, space, double quote, semicolon. That sure is a cleaner syntax for printing out something than this, right? If you had to choose one or the other, I'd go with that. All right, and so yes, the length of our array is 5, and it is printed out the array twice, which is appropriate because we called our print array function, and then we printed it out with a for each loop. For each loop. Now the C# language actually uses the word each. You type for each, but in Java and C++ you do not. It's just a different syntax between the parentheses. I am going to put a comment above this other for loop that says print an array with a for loop. So, array elements can be used as regular variables. Tests subscript 0 is 79. Just like if 79 is an int, you can store it in an int. You can also store it as an element of an array. You want to print out what are the elements of the array? Test subscript 0, just like it was an int. Input into tests, just like you input it into x or y or height or weight or whatever. Want to calculate? Oh, come on. Go back. Why'd you jump down there? Add two numbers and store them in another place in your memory? Totally great, just like x is equal to a plus b. If you do cout tests like that, this says it's not legal. It's legal, it just doesn't do any good. It prints the address. So here they've declared an array called hours, and it's got 6 elements. And so then it asks for, and this is a little too much typing, enter the hours worked for the employees. And then you're supposed to type a number in and it stores it in the first element. Type a number in and it stores it in the next element. Type a number in and it stores it in the third. Then it turns around and it prints those out. Print out the first number, and then the second number, and then the third number. Now whenever we start making programs that ask us to input lists of data, it becomes very annoying because each time we run the program it requires us to do that, right? But you got to do it. So let's declare an array of strings. String, and I'm going to call it colors, and it's going to be 3 colors. But I should put that 3 as a constant. So above that, const int num underscore colors equals 3. And then I'm going to delete that number 3 there and make it say num underscore colors. This is a slightly different syntax. Guys who've taken Java, if you remember, you put the braces there, right? And you also had to use the new operator. String square brace, array name equals new, you know, something like that. All right. Now let's tell them what we want. Cout, enter 3 color names separated by spaces. Cout and then hit return. ENDL. All right, so CIN, arrow, arrow, colors, element 0, subscript 0, index 0, square brace 0. CIN, arrow, arrow, into colors 1. CIN, arrow, arrow, into colors 2. Now we ought to print them back out. We could use a for loop. So C out, arrow, arrow, you entered these colors, colon, space, end quote, and then let's use a for each loop. That's the shortest syntax. So for, parentheses, string V for value, S for string, the word color, but whenever I start mixing plural and singular, color and colors, people start putting S's where they shouldn't. So I shy away from that, even though it's a great syntax, right? Don't type this, but if I type this for string color, colon colors, then I know that one represents the array because it's plural, and that one represents the singular variable. Great idea, but like I said, anytime I start doing that, people start forgetting S's in one place and putting them where they don't belong in the other. So every value in the colors array, string V colon colors, C out, arrow, arrow, color, excuse me, V, arrow, arrow, followed by a space. And then after all that, C out, arrow, arrow, ENDL. All right, enter 3 color names separated by spaces, hit return. Okay, red, blue, green. You entered these colors, red, blue, and green. So that worked. Usually you use a loop to input the data as well, right? Anytime you see a series of statements with a number that increments like that, instead you're going to use a loop. That's just a clear symptom that you should have used a loop there. We should have made a loop that counted from 0 to 2 and let the user input them. You cannot use a for each loop if the array has to be changed. It's kind of output only. The reason why is this V variable just gets a copy of the element of the array, right? You can't change it. Well, if you do change it, it doesn't change the original array. Kind of like if you have parameters in a function, right? You don't. And if you change the parameter value, it doesn't actually change the calling one unless you use a pointer or a reference, some trickery like that. So if we were going to write this as an input loop, it would have to be of that other syntax. For int I is equal to 0, I is less than 3, or num colors, and then read it in like that. We may as well do that. I'm getting itchy about writing another version of our print arrays code that accepts strings. Let's go do that. We have print array that takes ints. Copy all of that. Paste it. And we just have to change one word. Change this word int to string. Now we have overloaded that method so that we can pass it either an array of integers or an array of strings. I think this is something that these other languages do that Python does not do. The Python does not let you overload functions so that you can write one function name that accepts different data types. Could be wrong in that.
Python doesn't care much about data types to begin with.
Right, it doesn't care about data types to begin with, it just cares the name, so how would that work? Okay. Alrighty, so down here, where I printed out my array of colors, I could have just done this, right? Print underscore array, and then passed in my colors array. And it's complaining. No overloaded function matches the argument list. Well, is that so? Maybe if I rebuild it, it'll figure it out. Oh, why? Because I didn't pass in a length, right? It requires 2 parameters and we only passed in 1. So let's go back down to here, and when we call print array, we also need to pass in the length of the array. Comma 3, yeah, that'd work, but it'd be far better to use our constant, which was num underscore colors. Num underscore colors. Red, blue, green. It printed it out twice, as we would expect, because we printed it out by hand with a for loop, and then we called our function. Spoiler alert, know how to print an array with a for loop and a for each loop. Now when you declare an array, it's just got numbers in it that don't mean anything, values in it. It's called an uninitialized array. It reserves 5 spaces or 10 spaces or however many, but it doesn't fill them in with zeros, as you might hope. It doesn't bother. It doesn't take the time to do that. Now, since we are compiling in debug mode, see where it says debug? It does go ahead and fill it with a certain value, but not 0. If we change this to release, then it wouldn't even take the time to do that. Now, what do I mean by that? Let's declare a new array. Int more nums, parentheses 5. And then let's call our print array function with that. Print underscore array more nums, comma 5. And yes, I should have declared a constant for that 5. So when I run it, enter 3 colors, okay, blah, blah, blah. Check out what it printed. Garbage. Uninitialized variables. Like I said, since it was compiled in debug mode, the compiler went ahead and put some specific variables in there that, as you become more experienced, every time you saw that number, you go, oh man, I used some uninitialized memory. What if you want to initialize that? There's a shortcut way of initializing it. Int nums3 subscript 5, and then do this, equals curly brace 0. And then print that one out. Print array more nums, oh, excuse me, nums3, comma 5. It is going to be nicely filled with zeros. And there we go, right? The first time it printed out that bizarre value, but the second time it printed out all zeros. We used an initializer to fill them all in. Now the way the initializer works is you can specify as many values as you want up to this number. Right? I could put in 1, 2, 3, 4, 5 and print it out. I'm getting really tired of entering those colors. 1, 2, 3, 4, 5. What? Yes, sir.
Have you it's filled.
Yeah, absolutely. I'm sorry, I went too far without asking. And there we go, right? It initialized our array to the values 1, 2, 3, 4, 5. Now, an interesting thing about Java, which I do not believe is, excuse me, C++, which I do not believe is true about Java, is if you fill in fewer values here than you've allocated there, then the rest of them are formatted to 0. So if you just fill in 1 0 and leave the rest all blank, then it fills the whole thing in with zeros. If you put a 1 there, then it would start with a 1, and then there'd be 4 zeros behind it. So that's a quickie way of storing all zeros in there. Now I'm going to type a loop in that would set them all to 0 anyways, and then I'm going to do walkabout. So one more for loop. For int I is equal to 0, I is less than 5, I plus plus. See, I'm being really sloppy and not using constants. Nums3 subscript I is equal to 0. That's kind of how you did it in olden days. Before you had cool syntaxes like this that would initialize it out to 0. And if we printed it out again, we'd see that it was all zeros. All right. So we know how to access the elements of an array. Square braces, you put the index number in them. The number has to be an int or something that will translate into an int, like a byte or a char, something like that. Because you can't have item 3.5. Now remember when I said an array was not allocated with the elements initialized to 0? For some reason, the designers of C++ decided that if you make it a global variable, it is all initialized to 0. Oh, but while I have it compiled in release mode, start without debugging, do you remember those numbers? That, the negative 8 billion or whatever it was printing out? Instead, we see these numbers. That's just purely random data. Whatever was in those bytes before the program started is what we're seeing there, instead of those negative 8 millions or whatever when it was compiled in debug mode. And now that kind of looks like valid data. That could fool us if we looked at it, a printout of it. But it probably is completely meaningless. But we are seeing that there was some data there. I'm going to switch back to debug now. If it's a global array, all the elements are initialized to 0. If it's a local array, the elements are not initialized by default, and that's when you use this syntax, right? That'll make them all 0. I would do that even for a global array, just, to kind of reinforce the point. So there is no bounds checking in C++. When you use a value as the array, C++, unlike a lot of languages, does not check to make sure it's valid. So you can use subscripts that are beyond the bounds of the array. The following code defines a 3-element array, but then writes 5 values to it. Right? Our array size is 3. Excuse me, our length is 3. I really wish the textbook was consistent. And then I will store 5 elements into the array. And so it has a for loop that counts from 0, to 4. The limit is less than 5. And it writes in values in each one of those elements. So it fills in the first 3, which are valid, and then it writes into, whatever random memory is following the array. Passy into the array. So our array started at this address. It wrote that one, it wrote that one, it wrote that one, and then there's no man's land out here. You don't know what is stored in that data, but whatever it was just got erased by your 100s. So be careful not to use invalid subscripts. It will corrupt other memory locations. It may crash the program. It could even lock the computer. That's kind of rare now, but I suppose if you did it as a device driver or some low-level program, it could. And cause elusive bugs. Elusive because each time you run it, it may behave differently. based on what was written to those memory locations. Also, off by 1 errors. Off by 1 happens when you use array subscripts that are off by 1. So, you know, the computer wants us to use array index 0, 1, 2, 3, 4, 5, right, if it's a 6-element array. But our brain works like, okay, my first element's got to be 1. My last element has got to be 6. So if you code your array like that, then you're going to get an off by 1 error. Really. So here we have an array that starts at 100. We should start our counter at 0 and go to less than size. But we did an off by 1. We started at 1, and then we made less than or equal, which is great if you want to count from 1 to 100, but arrays of size 100 can only be accessed 0 to 99. Array initialization. You can initialize your array like that, curly braces. The names that are stored in the array initializer get copied into the array when the program runs. The initialization list cannot exceed the array size, right? So if size was equal to 4 here, but we tried to copy 5 elements into the array at array creation time, I don't know if it'll crash or if it just won't compile. I guess we could find out real fast. Don't type this because it's obvious garbage. Yeah, see, it's not even letting me compile. Thank goodness. However, you can do the other way. You can give it fewer initializers, in which case the first value would be a 79, but all the rest of them would be 0. That's why initializing something like this sets the whole array to 0. About time to stop. So if the array is initialized with fewer initial values than the size declarator, the remaining elements are set to 0. 7 numbers. The numbers we put in our initializer are 1, 2, 4, 8. So we have 1, 2, 4, 8, but the rest of them are 0. At least they get set to 0. At least they're not, you know, random memory, like if it was an uninitialized array. If you leave off the number between the quotes, the compiler figures out how big it needs to be to hold these numbers. So this would allocate space for 5 quizzes. You have to either use a declarator or an initializer list. Got to have one or the other. You can even have both, but you can't leave off both. Alrighty. Good place to stop. See if we have any homework about arrays. That is a good thing to drop on us at this point. Oh, we've already talked about arrays quite a while ago as homework assignment, in class L. Alright, create an array of 6 integers called nums. Write code that places the first 6 digits of pi into the nums array. There you go, I don't know the first 6 digits of pi. Okay, I give them to you, right? 3, 1, 4, 1, 5, 9. Then create an array called movies and use an initializer list to set the array elements to 4 or 5 movies you like. That's far enough. We don't know how to do this stuff. Let me delete that line of code and then print the movies array with a for each loop. All right, Dropbox time. This will be Q. All right, you're good to go. If you refresh the Dropbox, you'll see Dropbox Q. All righty. So I will see y'all Thursday.